Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. If you are new here, kindly share, like, comment and subscribe for more interesting videos and updates. If you are new here, kindly visit my previous lectures where I have dealt with piecewise functions into details. Today we are going to consider questions, okay, to throw more light on piecewise function. So if you have a graph, okay, of piecewise function, you are being told to write the equation or the formulas for those piecewise functions. What are you supposed to do? First of all, just consider one function at a time. So it means piece. Do you get that? So that function, that's a piece, and the other functions we call them pieces. Do you get that? So piece. Combine them, piecewise function. Right? Is that not interesting? Good. So just consider one piece of a function, write down the coordinates. In other words, write down the points. After that, what do? You look out for the gradient of that graph or that straight line. Afterwards, you pick the gradient and you pick any of the coordinates so that you can look or find for the intercept on the y-axis. Then after that, write your formula. And this is the same for all the functions. Then the last one is to just write down your boundaries or the restrictions or the conditions to make your function defined. Hence, piecewise defined functions. Okay. So we have this, okay? So let me label this as L1, L2. I've given you the steps, right? So we are going to write down the points of L1. Remember, it is a straight line graph. So we are going to look for the gradient of the straight line. So viewers here, for want of space, let's come here. So I'll say 4 for L1. What do I know? I know that 1, then 3.5. This is a point. And the other point, I have 3, then 2.5. Where from these? Viewers from 1 and 2. Okay, then look for the gradient. So, because it's line 1, look for the gradient of line 1. So I have M1, which is equal to y2 minus y1 over x2 minus x1, right? So this is x1, y1, x2, y2, as simple as that. Y2 to be what? 2.5 minus y1, which is 3.5, then all over x2, which is 3 minus 1. So therefore, I have 1 over here, right? Are you okay? So we have 1 over 2, which is the same as what? 0.5. So that is what? M1. Now you pick any of, you can pick any of the coordinates, either this or that. So which one should you consider? I'm giving you 3 seconds to think about it. Alright, so let's consider the first one. So I have 1, then I have 3.5. And I know the gradient, which is what? Half. Is that also good? So therefore, record that y is equal to ms plus c. Viewers, we've been doing this all this while, right? Good. So this is my y and this is my x. Why are we doing this? We are doing this because we are looking for the intercept on the y-axis. Do you get that? So what is my y? Y here is what? 3.5, which is equal to half. That's my gradient. Then multiplying x. X is what? 1. Then plus c. So I have 3.5. When you transpose this to the other side, I have negative half, which is equal to c. So c is equal to, by the help of the calculator, we are having 4, right? We have 4 here. Good. So viewers, 2.5 minus 3.5 is negative 1, right? So my gradient is negative, that's negative 0.5, right? So this is negative, right? Negative half, when you transpose it becomes what? Positive what? Half. So C is equal to 4, right? Good. What do we do now? Let's write our formula. You know that y is equal to mx plus c. What you do is is that also? You maintain your y, then you maintain your x. Do I know the gradient? Yes, the gradient equals what? Negative half, then times x. I maintain x and I maintain my y. Then plus my c. My c is my what? That is my 4. Okay, so 4. I'm done with the first one. So the next one is 4 L2. You just do the same. We have this point and the other point. So we have 5, 1, then we have 8, 7. So this is x1, y1, x2, y2. So gradient of 2 is equal to, what do we have? We have 7 minus what? 1, then all over 8 minus 5. So m2 is equal to, what do we have? 6 over what? Over 3. So m2 here equals what? 2. As simple as that. Recall that y is equal to mx plus c. Why are we doing this? We are doing this because we are looking for the intercept on the y-axis. So as a result of that, we need the gradient, which is equal to 2, then any of the coordinates or the points. So either this or that. I'm giving you 2 seconds to think about it. Which point should you choose? Right? So let's pick the first one. So I have what? 5, then what? 1. So this is x and this is my y. So we know that y is equal to mx plus c. So wherever you see y, y goes to 1. Wherever you see x, x goes to 5. So I have 1 is equal to, do I know my gradient? Of course, yes. Which is what? 2. So I have 2 times x, which is 5, plus c. So I have 1, then minus, when you transpose this to the other side, you have what? Negative 2 times what? 5 plus c. Sorry, equals c. So therefore I have 1 minus what? 10, which is equal to c. So therefore c is equal to what? Negative 9. Now to write the formula or the equation for this, remember, you maintain your x and your y. Is that not so? If I'll maintain y, then I'll maintain x. What is my gradient? Remember, our gradient was 2. Because I maintain y, I'll maintain my x. What about the c or the intercept on the y-axis? Remember, it was negative 9. As simple as that. Now, so we say let the function f of s be equal to y. We want to write the overall formula, okay, for the function. In other words, we want to write the formula for the piecewise function. So let the piecewise function be this. So what do we have? Viewers, this is one function. We are going to write this, right? So negative half x, then plus 4. Okay? Then this function, which is what? 2x minus 9. For what values that will make the function defined. And this also, for what values that will make this function defined. Let's do justice. Viewers, from here, realize that we have 1, right? This is 1. That means x at 1. This is it. This is 1 over here, right? And this side, we are considering the x values. This is 3. So that means this is 3. And remember, this is what? This is closed. Okay? This is closed at this point. This is also closed at this point. So that means the interval becomes what? So it's from 1 up to 3. So you have 1 less than or equal to, you see, this means what it's close, equal to x, then less than or what equal to, because it's also close at what, at 3. As simple as that. So we are going to do that. So I have for 1 less than or equal to x less than or equal to 3. Then this, yeah, the same thing. Look, this is 5, right? So from here, this is 5. Then here, this 8, right? So I have 8. Okay, 8 over here. So that means from here up to here, this is close at this point. This is also close at this point. So you can say that 5 less than or equal to, right? X less than or equal to what? 8. So these are the possible values of x that will make the function define. As simple as that. So I have 4, 5 less than or equal to x less than or equal to 8. Viewers, this is the end of the tutorials. Okay, so far as Tindanious Maths and Science YouTube channel is concerned, we are going to learn a lot. Stay tuned for more interesting updates and videos. Bye.